the system, this matrix, meaning this system of equation lah. So matrix come from system of equation. So how to solve this system of equation? So we will have this. This is inverse. It's the inverse. So we want to solve what is value of x, what is value of y. So we have, okay, what is value of x, what is value of x2, which is satisfied both equation. We want both equation. So now both equation. So we have a few type of solution lah. So some system of question we have only unique solution, only one solution for this. For example, this. So usually.
Excuse me, doctor.
Yeah.
Did you share screen?
Oh, sorry, I'm not sharing yet. Alright. So type of solution. We have type of solution. When I'm recording, I record. So we will go to system of equation. We need to find what is the solution for the system of equation. So when we deal with system of equation, so we will have a type of solution, which is some solution we call it as a unique solution. Unique is meaning we have only one solution. How we identify this type of solution? So how we identify if there exists this kind of this is maybe A1, A2, this is 0, 1, A3, A0, 0, 1. So we have, if we have this type of solution, we have B1, B2, B3. So if we have this type of solution, so where A1, A2, A3 from a real number, meaning including 0 lah, 0, 1.2, or any numbers lah, in real numbers. B, so B also B1, B2, B3 is also a real number, meaning if B3 equals to 0, this system equation will have only one solution. For we can solve this solution, this system of equation with one solution only. Okay, if B3 equals to 0, B3 equals to 0, B3 equals to 0, so we have this matrix. B1, B2, 0. So is it similar with this matrices? Is it similar? Which is represent a unique solution, only one solution. Yeah. Huh? Not clear lah. Please repeat.
Similar
similar. What is the similarity?
Similar, because it, because as long as our matrix here is 1 1 1 here, okay, and then the rest is 0.
Okay.
Alright, so so meaning here x3, here x3 equals to 0, x2 plus a3 equals to b2, x1 plus a1 plus, oh sorry, sini tak ada x, this is x2, x3, so x1, okay, x1, and then we have what is this, and then we have x1, a1, x2 plus a2, x3 equals to here lah, b1. So we can put x3 inside here, is x3, so that we can find the we can find b2 is a real number, so we can find the x2. After we find x3, x2, and then we can find x1 by putting the value here, x2 and x3. So here in without number, but make sure the pattern is like this. The pattern is like this. Just make sure pattern like this, so it will be a unique solution. So the system will be infinitely many solution if this will be happen. Meaning, if we find the matrix, we have 1, 2. For this matrix, we have 1, 2, and then we have 4. We have 0, 0, 0. So meaning, if you have any matrix A1, A2, usually is not A here. Usually is 1. So if after we find the inverse of the matrix, we will get this 1. We get this something number, a1 maybe, a2 here, and then we got here 0, and then we got 1 here, we got a3 here, and then we got 0, 0, 0. So this is b1, b2, b3. b3 is 0. So b3 is 0. No battery here. So if we got this equation, so remember this matrix will be infinitely many solution, because 0s1 plus 0s2 equals to 0. So to be honest lah, so equals 0, so there is 0. But if we have 0 times something number plus 0 times something number, you should have 0, because anything times 0 will be 0. 0 plus 0 equals to 2. So this is not correct lah, right? This is not correct. This condition not correct, not equals to 2. So because of this condition is not correct, so we cannot find the solution. That's why in mathematics the value, we learn about value. If no solution, we state that is no solution. If has solution, we state that it has have a solution. If 3 by 3 matrices, what should we do? If 3 by 3 matrices, we will have, for example, we have 1, 2, in general lah, I put in general, maybe A1, A2, 0, 1, 0, 0, A3, sorry, A3. So 0, 0, 0, and then we will have B1, B2, B3, and where B3 not equals to 0. Okay, so with this condition, so we will have this system of equation is, so we can conclude this system of equation have no solution. Alhamdulillah. Okay. Okay. So remember this. So we have three types lah. One is a unit solution, which is 1, 1, 1. And the infinitely many solution, which is we have 0 equals to 0. You remember 0 is equals to 0. Not 0 equal to something number, no. So there is no solution if 0 equals to something number. So that is not correct. So we said that as a no solution. Okay. So this is inverse of matrices. So inverse of matrices. So we have this system of equation, and then we put it in a system in a matrices. So we can put like this: A inside here, and then X inside here, and then the solution will be at the right hand side after equal. So we have AX plus B. AX plus B meaning this matrix, and X is the variable that we want to find, and B is a solution. Where A is a square matrix, note that A and B are matrices with numerical element to find an expression for the unknown. Okay, so now you need to remember matrices involve position. Okay, position is very important. For example, okay, matrices. So involve position. So position is very important. So matrix. Matrix, RI. Matrices. Okay. Real number. Real number operation is different lah. So if we say that AX equals to B is not similar to XA equals to B. This is matrix. If I say B A equals to AB, so that is not correct. Okay, not correct, because the inverse position and the size of matrices is different. But if a real number, so BA is equals to AB. For example, 2 times 5 equals to 5 times 2. So we have 10. It is 10. But here not. For example, we have 1, 2 matrices. And then we have 1, 0, 1, 1. So not equals with A. What is A? A is 1, 0. 1, 0, 1. So 1, 2. If you process this, so we will get not equal. So it's 1. First row, first column. So 1 plus 2. First row, second column. 0 plus 2. First row, first column. First row, first column. First row, second column. No, so no second row. Second row, first column. No, we just have this. So this is 1 by 2, 2 by 2. So the end we will have 1 by 2 matrices. For here, what you will have? You will have first row, first column. So 1. We cannot compute this because there is no partner for 0. So cannot compute. So there is, sebab it should be this is 2 by 2. So you should be 2 by 1. So we will get, but here is 1 by 2. So it's not equal then. So cannot compute because 0 no partner for 0. Okay, so that's I mean what is the most important for the matrices is position. Okay. Okay, so what we'll have here, so if we times, so we have ax plus b. So ax equals to b, right? So if we times left hand side, at the left hand side, so both at the left hand side. If right hand side, both is right hand side. So you cannot change the position. So let's we times with A inverse. So A inverse, so there is also A inverse for both sides. So A inverse times A, we will get I x equals to A inverse B. So I times x we will get x, and then A inverse B. So we will get the solution of this system of equation. So now why we times Ix, we will get the x diri sendiri. Why we get the x matrix itself? Why we times identity and then we get the itself? Why?
Because it will be the like 1 0 0 0 1 0 and 0 0 1.
Okay. Because of okay, for identity, anything with times identity, we will get that's number lah. So for example this. So for example, multiplication identity for the multiplication for the real number. So we have 1. So anything times 1. So for example times 7. So we get 7. if 7 times 1, we will get 7. 10 times 1, we will get 10. So in matrix, we call it as identity. In a real number, we have 1 as an identity, but in matrix, we call it as a capital I. So there is a capital I, which is we have any number, any matrix, okay, any matrix. Okay, we have any matrix. Okay, for example, we have any matrix in general lah. In general, we have any matrix for I. So I will be 1. For example, we have A1, A2, A3 until AN. So we have 0, 1, A, B lah pula, B. Okay, B1, B2 until BN. And then we have 0, 0, 1, something number C1 until CN. So this will be continue until n number of rows. So there will be 0, it will be 0, here will be 0, but here there is continue and still 1. So there is 0, so there is 1. So there is any number, C, D, any number lah, any number. So 3 dot meaning continuous, 2 dot is no meaning, 1 dot is full stop. So 4 dots meaning no meaning, but 3 dot is continue, meaning this continue. Okay, so we have this kind of identity of matrices. So now we want to so identity is no number here, sorry. It's no number here, sorry. Alright, sorry, it's confusing here. No number here, it's 0 actually, 0. That is identity. Right. So we have 0, 0, 0 until n0. N term lah. And then 0, 0 until 0. So 0, so 0. So we will get, they will have a square matrix with 1 only in a diagonal. Alright, so now I want to times with a star. Well, if we times with a star, so what should? So for example, I times with A11, okay, A11, A12, A13, continue until A1N, A21, A22, A23, continue until A2N. And then I have 2A31, A32, and then I have A33, continue until A3N. So it is similar, but this something number inside there. So we will have the AN1, AN2, AN3, and then AN. So times this identity times something matrix. So this n matrix identity for n matrices times with n matrix. So we try to solve this. Okay, first row, first column. So we'll have x1 times a11 plus 0 times a21, okay, plus 0 a31 and plus continue until 0 plus 0 a and 1. Okay, first row, first column. First row, second column. First row, second column, we will have okay, 1. First row, second column. First row, second column, you will have, okay, here this is 1 2, so first row, second column, so 1 times a12 plus 0 a22 plus 0 a32 plus until 0 a and 2. So second row, first column, so you will have 0 0. How to reduce the view here, option. Okay, 0 a11 plus 1 a22 plus 0 0 second row, first column, a21 second row, first column, so 0 1 1 1 1 2 1 2 1, sorry, 2 1 0 a31 plus until 0 a and 1. Okay, continue until, okay, second row, first column, second column, second column, so this is 0 a12 plus 1 a22 plus 0 a23 plus until 0 a and 2. Okay, you have question? Something wrong? Okay, all right, so if you continue, so you will get the result is you get the same result. Actually, you will get this matrix. If you continue you get this matrix, because they will eliminate for number. So for example, we have so we have this is 0, so 0 0 0, so we get a11, so 0 a21, there is a value there, another the rest is 0, so this is 0, so this is 0 and the rest it will be 0, only one term only, so it is 0, so this is 2 by 2, so 0 0, so that is the same lah. So this is second term, so you will get 2 2. The upper one we have 1 2. At the left hand side is we will get 1 1 or 2 1. For this is 2 1. So if you continue, so if you continue, you will get 0 a11 plus 1 A21 0, sorry, 0, and then plus 0 A31, continue until 0 1, sorry, this is 1 AN. So the rest will be N1, sorry, N1, it's N1. So we will get the same thing. If the last term also the same thing lah, because of the properties of identity. We call it as a properties of identity. If we times with identity, we get that's number, that's matrix itself. Okay, that's why here, if we get the identity, if matrix with any identity, we get Ix, and then we can eliminate x. Ix equals to x. So here we can solve this system of equation by using inverse of 1 and then b. Alright. So it is a theory of how to find the solution for the matrices. So now we go to the example. So we have these matrices solved by using A inverse and inverse of the coefficient of matrices. So for this, first of all, make sure the variable is equal to each other. So if not equal, for here we have 0 x 1, you will miss later, because if you put the wrong position, wrong number for the matrices, you will get wrong answer. Very, very important. For here we need to add 0 x 3. So now we perform with the matrices. So we'll get 1, negative 1, 1, and then we get we will get x1, x2, x3. So equals to, usually you will get, if you properly write, you will get 2 marks here. Okay, 2 marks here. Okay, make sure you put in the correct way. Okay, so we have 0, 2, negative 2, 1, and then we have negative 2, negative 3, 0. So we have these matrices. Okay, we have these matrices, and then we have x a, x equals to b. So b is 2, 2, 3. And then we perform, we need to find A inverse. Is depend on the question, how to find the A inverse. So here they use a cofactor to find the inverse. Then you get this, right? And then after you find x equals to A inverse times b, so there is you need to add more operation here, which is you times this from this matrix, 2 matrix. So 3 times 3 times 2 plus negative 3 times 2 plus 1 times 3. Okay. And then negative 2 times 2. Second row, first column. So second row, first column, we have negative 2, 2 plus 2, 2 plus minus 1 times 2. Okay. Negative 4 times 3 times 2 plus 5 5 times 2 minus 2 times 3. Okay, and then you solve this equation, so you will get 3, negative 3, negative 4, and then you make the conclusion. So make sure everything you put in your writing. Okay. Okay, let's try for this. So you want me to try exercise 1 or 2? Class, are you here?
Exercise. Try exercise 2.
Huh? 2. Okay.
Number 2.
Number 2. So make sure here x3. So missing here is 0 x2. So here is missing 0 x3.
X1.
Here is 0x1. Okay. So we made the system of equation. We made a system of equation. We have 2, 0, 2, and then 5, 3, 0, 0, 3, negative 4, and then there is our matrices A, and then we will have x1, x2, x3, and then the answer will be, there is 2, 4, 4. So if you're able to make this system of equation, you will get 2 marks for upload solution. Okay, later there is upload solution. Our exam is after your mid-sem break. We combine 2 chapter, vector and matrices. Okay. So after we get there, you need to find the inverse. How to find the inverse? How to find the inverse? We can use online calculator, inverse matrix. Inverse matrix. Inverse calculator. I think here. Okay. You can find inverse matrix. Okay, here you can use Gauss-Jordan elimination, Cramer's rules, inverse matrix method. So I try inverse matrix method. Okay, so we have a 3 by 3 matrices. So we will have what is the value here? We will have 2, 2, 0, 0, 2. Even though you have a calculator, make sure you can convert it by your handwriting, so that you're not missing the marks lah. Okay, a lot of mark will be given. So make sure you can convert into a marks. So now, since online, you can use this, practice this, so that you can easily to score lah. I hope you can score, but still need practice. So I click solve. Oh, there's no data here, so it's 4. Okay, and then solve. So solve show they use inverse ERO, I think. They use ERO. Calculate the inverse. So you need to click what? You need to click the solution, show all solution. So the solution will be to -4, 8, and 5. Okay. So maybe you can use by using Cramer's rules, inverse matrix. Inverse matrix here. This is inverse matrix, just a set matrices. So maybe you can just use inverse matrix first, and then later, because we need to find inverse first, there is a lot of marks there, So we need to find inverse first. 2 0 2 5 3 0 0 3 -4. Every details you need to take here. Every detail solution calculate. Show solution. Is ERO lah. But a few row you just can remove. You just what? You just put only for only the marks given. Okay. First of all, this but 530 and then okay, this one mark here. You need to copy here this. For this, multiply with 5. This you do not need to put in your solution step, because this is the method from the online calculator. But we learn about, we just directly go through this step. Okay, no need to put here this 5 and so on. We just put this directly. No need to write this. You just write this, and then you continue until this part no need to write, but this part you need to write. But you need to know what is the operation there. So please make sure you know to use this calculator, so that it will help you in your future. Okay. And then recalculate. Okay, recalculate by using determinant. Maybe determinant. You can what? You can try lah at your home. And this Wednesday we'll solve. You try to solve tutorial so that we can discuss this Wednesday. Okay, I put the link at the comment. Okay. And as usual, as your attendance, please do this one. Okay, do this one. Put every single what you call it, step, so that you not miss a mark. For example, this mark in this, from here to here. Also there is a mark, and then a conclusion. We also have a mark. Okay. Okay, so later we will find to use Gauss elimination and Gauss-Jordan elimination for the finding of inverse and solve the solution. And then we have Cramer's rule. So 3 type of method lah we can use to solve a solution, to find inverse and directly, or to find inverse and solution, or to find directly the solution without to find inverse. For Cramer's rule, we not find the inverse, but we directly use the formula to get the inverse. Okay, alright. We rest 10 minutes. Okay, we'll see 9 at 9:10 lah. At 9-10 minutes. Okay, you can rest for a while. Okay, make sure and then as usual, go to the Padlet and paste your calculation. I want to see what is your calculation for this system of inverse matrices. For those from RK 90, engineering, agriculture, right? Agriculture. So you do not need, because I already I already put in at your I already discussed last Wednesday, right? So you just can get a rest and then come back at 9:10, right? 9:10 a.m. Alright. Is it okay? Another group of mine, RK90. Is it okay?
Okay. Okay, doctor.
Okay. Hope you can I just make sure what? Maybe RK90 just refresh, but later we will go to the application. So application I'm not teach you yet, so it's okay. So later lah, alright? Yeah, so maybe you can move and rest first. So next is Gaussian elimination and Gaussian-Jordan elimination. Gaussian-Jordan elimination Gaussian elimination and Gaussian-Jordan elimination. Kita letak we put the solution here, B1 B2 inside of the system of equation. So before this we not put inside of matrix. We just put it at outside here. We just handle for this first. We find A inverse first, and then after that, after we find the inverse, we times with the solution. So for the net, we just put the solution in beside there, right? And then you can use ERO, and then reduce echelon form, or elementary, or reduce in the reduce row echelon form. So there is a difference between elimination. So for example here, by using elimination, so you just stop if you get this triangle. You can stop there, and then after you stop that, you put into the system of equation, which is for here we can find x3 equals to 2 x2, and then x3 you plug into this equation, and then you get x2. After you get x2, you plug in x3 value and x2 value in this equation, and then you will get x1. So but for Gauss-Jordan elimination, you find out until identity here. Okay, until identity here. So there is a solution. Okay, so and then for the Cramer's rule, so for this, for 2 by 2 matrices, so we put B. For x1, we put the answer in the first row. For x2, we put answer the second row. If we have a third row, first answer at the first column, and then the second answer. If x2 second column is x3, if we have x3, meaning as at the third column. Okay, this answer, right? So here there is example. Okay, there is example. We have 3 variables. So B1 is first column for x1, and then second column for answer, plug in into this matrix, and then B answer here. Okay, x3. So and divide by determinant. So we need to find the determinant of this matrix, 3 by 3 matrix. Okay, this is the process. So first of all, for example here, you just put, then you will get directly from the formula. Similar here, it's like more simpler. So D we can put in outside here. D equals to what? D equals to 1, 2, 1, 2, negative 1, negative 2, 2, 2, 3. So we'll get negative 13. So you can use the calculator. Alright, so next, for example, okay, so please make sure you put everything so that you can get the formula, the marks. You not lost the the marks. Okay, for example here, the process here you also need to put, because we give a lot of mark in for the process. Every step you get that value, the answer. Okay, for example here, so we have 1, negative 2, 3, and then we have 9, negative 1, 3, 1, negative 2, 2, negative 5, 5, 17. Okay. Okay, so now we use online calculator. Okay, we have online calculator. So you just only click the Cramoso, for example, Gauss-Jordan elimination first. So 3 by 3 matrices, matrix. Okay, so we will have 1, negative 2, negative 2, 3, and then 9, 1, negative 1, 3, 1, negative 2, 2, negative 5, 5, 17. Okay, click every detail solution, solve. Show solution. So you will have this, and then you create from this answer, from online calculation, from online calculator. You need to create this flow from this here. What should you do? So you make this one, so the original already 1, so no need to put anything. So the second row you want to make it 0, so you find the negative 1. You need to what, to analysis this formula, how to get here by using this. So it will help you to put what is the operation here. Okay, very important. And then you just try to make sure you can convert into the step given that you already learned. Okay, make sure that only make sure that. If not, you just put you use only I just apply what I teach before. First step is what, second step is what, and then at the online calculator you just verify your formula, your step. Alright, verify your answer. You will get that thing. Okay, and then So we got until this. Okay, until this. Until this. Okay, until that point. So, and then you transform into this formula. Then you just substitute manually. Make sure you give a right method, because if wrong method, so you will not get the marks. Make sure you give a right method. Okay, so for here you just get it from the matrices. And here is example for this. Okay, for until now, is it clear or still not understand what I'm teach today? Do you understand? Hello. Do you understand?
Yes.
Clear, or something you have a question or anything else you want to ask?
Madam,
Yeah.
when we answer the question, we need to write the operation to find the inverse matrix, or just we find it on different, or we can just write the inverse matrix.
Kalau soalan dalam bahasa Melayu ni macam mana tu?
Okay, kan kalau dia suruh cari, kalau soalan tadi kan, nak kan kena cari inverse matrix dia tu.
Okay.
Kaedah nak cari inverse matrix tu kena tulis juga dalam jawapan.
Biasa soalan akan tanya, as usual, the question is already state what the method you should do. Is it to find inverse by using Gauss-Jordan elimination, or by using Cramer's rules, and so on lah. So make sure that you not change the method. Meaning you understand if this method what the element you should put, so that you get the correct you get the the marks. Because if you do not put, there is no mark. Even though you correct, answer is correct, but the method is not as stated at the question. So the question lah first. The question, what is the question need first? You need to identify what is the method. If not state, meaning you can use A inverse first. You find the inverse first, and then you put x. If already, do you put your answer at the Padlet? Can I see?
No, not yet.
Not yet. Okay, for example here, if like this, okay, this we will get 1 minute. Okay, they put here, so there is putting in this system of equation M1, the right entries A1 usually. So how to get this A1? So it's not proper, right? So you should make it small, more flow. So you flow of answers. Okay, you should make it a flow of answer so that here you can know what step next. So it's not like this lah. So it's quite difficult lah me to identify where is your mark and so on. But still okay lah, because everything inside there. Okay, and then addition, adjoin first, find the adjoin and then transpose. Okay, you get this mark, and then you find A. What is A? The determinant of A. So this is already mark. Maybe 2 marks here also. So here 3, and then after that you put inside here. There is A inverse, and then A inverse. Okay, A inverse. So it's clear to me. And then maybe you can first, you still put in this form first, but it's still okay lah, still. But if you put in this form and then later conclusion, x1 is equals to -4, x2 equal to 8, and so on lah, x3 equals to 5, and so on. Okay, so for example lah, if you see your writing, okay, SB, this is equal, should be equal. Okay, and then nampaklah satu-satu kan, it's one, but step by step you put it, so it's more easier. Okay, sama je, cuma tadi ni macam ada kiri kanan, lepas tu masuk balik, macam banyak dia punya ni, jadi pening. Kalau saya macam tengah pening, susah sikit lah. So make sure your handwriting tu kemas, right? Very good lah. So macam ni. So labeling for this case, for this case, yang ni for this case, this part no need to put lah. This part no need to put. Just make sure Cij is equal this, and then no need this Cijt equal to this. And then you find this and you put here. So I already understand lah. So AXB equals this. Make sure it's proper, right? You properly write the equation one by one. So don't worry. If you have no time, make sure you let me know. So I know maybe I can consider to give you extra time. Alright? Make sure your handwriting is very clear, one by one, step by step. Alright? No need to rush, but make sure you get first of all, when you get the question, first of all, what is the question need? So what is the trick there? And second, the third is how we can solve. Is it by using what? So just construct your mind like that. So it's more easier lah, because mathematics is one to solve you in your life, to make it easy. No need to remember, but just understand, because every step there is a reason. Okay. If we put it like this, cannot lah. You lost a lot of marks. I look like you understand, but you will lose a lot of marks. You will lose a lot of marks because you miss something like this. So this is for Gauss Jordan. For the to find inverse first, you do not need to put answer outside. But if the Gauss Jordan, you put it need to put this answer inside. That is the difference, okay? You need to identify what is the difference between those steps. So you will score lah. I hope you can score. Right? Okay, now next is eigenvalue, eigenvectors. Dah nak habis dah. Alright. What is eigenvalue and eigenvector? What is eigenvalue? What is eigenvector? Cuba. Try. It's okay, it's wrong.
Eigenvalue is divided by
Tak faham. Tak faham apa dia cakap kan?
eigenvalue is AX.
AX. And then lambda x. What the mean? What is the meaning of eigenvalue and eigenvector? So it just give us AX equals to lambda x, meaning this matrix is equal. So what is this actually? This is something maybe if a matrices if a vector we have 3, 4. If matrices we have 3 variable. So S1, S2, S3 maybe. So this maybe what we call it as is a eigenvector. Maybe we have the same matrix in the same but at another what we call it at another place, but it is a same vector, a same matrix. We call it same matrix, but maybe it is another position. So that's why dia kata, because he said that if we have n by n matrix, so the eigenvalue and eigenvector x of A are defined by Ax equals to lambda x. Equivalently, x is said to be eigenvalue, x is eigenvector, x is eigenvector corresponding to lambda, which is lambda is eigenvalue. So so now we need to find what is if we have A and X matrix, and then we need to find what is eigenvalue of A. Okay, eigenvalue of A by using this. So we will have this. Yeah. Alright, so we can we try to manipulate this formula. Okay, he said that Ax equals to lambda x, and then x is not zero matrix, not zero matrix, but something matrix, some matrix, a matrix, a value matrix lah, not consists of all zeros element. Right, so we move this term into the left hand side. So we'll have Ax minus lambda x, okay, equals to 0. So now we factor out x, so we will have ax minus, no, no, no. Factor out x, we will have ax, a minus lambda, bracket x equals to 0. So we already know x cannot be 0. Cannot be 0. So anything, this number, this matrix times this matrix should be 0. So the only possible will happen to be 0, to make this equation 0, is a minus lambda should be 0. Should be 0. Okay, because we already defined x cannot be 0, so for sure it is not 0. So this is on 0, it should be 0. So we will find this a minus lambda. We have non-trivial solution if a minus lambda r is not invertible, and then determinant of this will be 0. So you give us a type of step lah how to solve this eigenvalue and eigenvector. So let's we move to the example. Okay, example we have this. Find the eigenvalue and eigenvector of each this eigenvalue of matrix using Gaussian elimination method. Okay, first of all, we know if so first of all we know a minus lambda equals to 0 for the determinant. Okay, so now what is a here? What is here? What is a? A is 0, 0, negative 2, 1, 2, 1, 1, 0, 3. And then minus lambda. Minus lambda. So kat sini bila minus lambda, we put I, lambda I, identity. Identity. What is identity for this? So 1, 0, 0, 0, 1, 0, 0, 0, 1. So that's why, and then we multiply inside this matrix. So we will have, okay, 0, 0, negative 2, 1, 2, 1, 1, 1, 0, 3, minus lambda 0, 0, 0, lambda 0, 0, 0, lambda. So we will get minus lambda, and 0, negative 2, 1, 2, 2, minus lambda, 1, and then 1, 0, 3, minus lambda. Okay, we get this. Okay, after we get this, we need to find determinant. This we should find the determinant. So should find the determinant. So we denote as this. So that's why we get like this. Determinant of this. So we use to find determinant. So we use the number that have a lot of zero. What is the row a lot of zero? So this row. So this should be plus so plus 0 and then macam biasalah. So 1 1 1 3 minus alpha. Because this is 0, so they do not put inside here. And then you solve this equation. Find the determinant of this. You will get this. Okay, you will get this. After you get this, you factor out 2 minus lambda here. After you factor out 2 minus lambda here, so P lambda, P is polynomial, 0 lambda, negative lambda, 0, negative 2, 1 minus lambda, 1, 1, 0, 3 minus lambda. Okay, and then you got negative lambda times cari determinant of negative 2 lambda, 1, 0, 3 minus lambda. Okay, and then plus 0 1 1 minus 3 minus lambda, and then plus negative 2 1 2 minus lambda, 1 0, and then you all akan dapat negative lambda. Okay, and then 2 minus lambda, 3 times 3 minus lambda, 1 times 0 times 1, so 0, so minus, okay, minus 2, okay, 2, and then bracket 0 and then minus this is 0 minus this, so minus 2 minus lambda. Okay, 2 minus lambda. So now this only for this term, so we have 2 term here, so 2 term, make it easier. So we have negative lambda, 2 minus lambda, 3 minus lambda, and then we have positive 2 minus lambda. Factor out lambda, factor out 2 minus lambda, 2 minus lambda, you will left with negative lambda, 3 minus lambda, plus 2. So you will have expand this, so 2 minus lambda, you will have negative 3 lambda plus lambda square plus 2. By using quadratic formula, so you can factor out this, you will get what? Okay, you will get this is, you want 2, so 1 2 negative, what is this, x, lambda square is 1. So negative 1 at 1 1, so negative, so there is lambda, so negative 2 lambda, there is lambda square, negative lambda, so we add here, we get negative 3 lambda, so lambda minus 1, or you can put this as a lambda minus 1, and then lambda minus 2. Okay, once you get this, so you need to find every value of this. So this equals to 0, so meaning 2 minus lambda equals to 0, so lambda equals to 2. Lambda minus 1 equals to 0, so lambda equals to 1. So another one is lambda minus 2 equals to negative 2, 0, so lambda equals to 2. Okay, so every lambda here you need to find the eigenvector. So you put inside the lambda first matrix here, the value of lambda here you put, and then you get these matrices times this. You will using Gauss-Jordan elimination, so at the end you will get this kind of formula, this kind of matrices. So we know that there is 0 0 0 equals to 0, so meaning 0x1 plus 0x2 plus 0x3, so we have infinitely, it is equal to 0, so infinitely many solution. So it can be infinitely many solution. So let's assume x3 equals to s ni maybe any numbers lah, so we know that x2 equals to x3 equals to s, so s2 equals to s also. So we have to, so here x1 plus x2 is equal to s, so plus s plus s, s3 also s, so equals to 0, so x1 equals to negative 2s. Okay, negative 2s. So how to put here? So we put in s1, s2, s3, so equals to negative 2s, s. So factor out s, so we get negative 2, 1, 1, and then bracket s outside. So we get this. So thus the eigenvector corresponding to lambda 1 equals to 1 will give this. For 2, so you put inside here, and you solve by using Gauss-Jordan elimination, and you get this matrices. Once you get this 0 0 equals to 0, 2 row, so meaning 2 variable you need to deal. So first of all, maybe we can put s3 equals to s, and s2 s1 plus s3 equals to 0, s2 equals to t, and another number lah. So anything, another number is okay. Make sure not the same thing. Is okay, it's not same. Because there is 0 also here. Okay, so how we need to transform into this formula? So S3 equals to S, so S1 equals to negative S, because S3 here, so negative S. So we try to put S1, S2, S3. So you will get S1 negative S, and then S2 equals to T, and then we have S3 equals to S. So now can we put like this? Negative S plus 0T, and then 0S plus T, and then we have S plus 0T. So what we get, we will find this negative S 0S S plus 0T plus 1T plus 0T. So and then we will have, okay, can we put this S outside and T outside? So we will get negative 1, 0, 1, and then put outside S, and then plus 0, 1, 0, T. This is T. So this is X1, X2, X3. Okay, so we get this solution. So we need to find this like this solution. Okay, so this is the exercise you can try, and then there is for application of matrices, where we use the matrices in our life. So you can read here. So this Wednesday we will discuss on the tutorial, everything on tutorial, or anything that you want to ask this Wednesday. Okay, so I hope you can manage to set out everything inside this tutorial. Okay, hopefully at the end of the next Wednesday, you can upload your solution for matrices. Okay, hopefully you can solve it lah, and submit to me with the correct answer. Okay, lambda tambah tolak lah, tolak lambda kuasa 3 tambah 4 tolak 2 lambda. So tolak 8 lambda tambah 5 lambda kuasa 2 tambah tolak lambda kuasa 3 tambah 4. So ni dia punya paling simple. So simplify kat sini. Oh, dia factor out terus 2 tolak lambda, lagi mudah lah. Okay, sepatutnya you simplify and then you factor out lah. You kena factor out. Nanti guna calculator online lah untuk factor out tu. Kejap. Mana tadi ni? Oh, dia factor out yang ni. So dia factor out yang ni. Boleh juga dia factor out yang ni dengan yang ni, keluarkan. So tinggal yang ni. Okay, so kalau kita tinggal yang ni, bermaksud Okey, nanti kita pergi ke online calculator. Online calculator. Simbol. Simplify lah. Factor out. Dia tak ada factor out apa tadi? Tolak 8 lambda boleh letak sebagai y, tambah 5y kuasa 2 tolak 3 tolak y kuasa 3 y kuasa kuasa 3. Okey, tambah 4. Kita tambah 4. Factor out. Boleh tak factor out? Factor out berapa tadi? Kita tulis balik. Factor out tolak 8. Okey. Tolak 8 y tambah 5 y kuasa 2 tolak y kuasa 3 tambah 4. Tu. So, dia akan dapat ni. Okay. So, kita akan dapat ni. So, kita akan dapat. Okay, kita akan dapat. Okay, kita akan dapat negatif y tolak 1 y minus sorry lambda lah sebab tadi lambda tolak 1 lambda tolak 2 kuasa 2 negatif lambda jadi 1 tolak lambda. Okay, and then lambda tolak 2 lambda tolak 2. Okay, so situ dia. So dia akan dapat ni lambda tolak 2. Pening sekejap. Tak dapat sama pula. So x1 lambda 1 dapat 1, lambda 2 dapat 2, lambda 3 dapat 2. Sama je. Okey, so inilah bermaksud kan dia kata benda ni akan jadi kosong. Sebab apa yang kita cari ni? Kita cari determinant ni. Dia ada apa palang-palang ni. So sama dengan kosong, macam mana nak jadikan dia kosong? Either yang ni kosong atau yang ni kosong. Yang ni kosong atau yang ni kosong. So 1 lambda 1, lambda 2. So lambda 1 equals to 1. lambda 2 equals to 2, lambda 3 equals to 2. So bila you all dah dapat lambda, so letakkan dalam equation ni. So so yang ni kita akan dapat dapat benda alah ni, and then kita darab, kita nak kena cari, tengok formula dia ni, kita dia dah tulis lah step dia. Okay, once dah cari equal to 0 dan dapatkan eigenvector dia lambda, so this equation ni, and then step 3 this equation is non-zero if and only if find the eigenvalue and eigenvector. So sekarang kita hanya baru ada eigenvector, sorry, this is eigenvector. Sekarang kita nak cari eigenvalue. Eigenvalue kita kena masukkan eigenvector dalam equation ni, matrix ni, and then dapatkan ERO dia, cari inverse, dapat kita try to solve the solution untuk matrix ni. Okay, kita try solvekan matrix ni. Cuma beza dia value ni selepas kita masukkan lambda tadi. Okay, dah lepas masukkan lambda tadi, and then dia buat Gaussian elimination separuh, and then yang ni dia jadi infinitely many solution. Sebab so sekarang ni kita ada 3 variable 2 solution. So macam mana nak settle out this thing? So sekarang x2, so kita ada this equation. So x2 sama dengan x3. Okay, x2 sama dengan x3 kan. So sekarang ni daripada sini, x1 sama dengan tambah x2 sama dengan x3, x2 tambah x3 sama dengan x2, so sama dengan kosong. Okay, so saya nak jadikan subjek x1 sama dengan negatif x2 plus negatif x2. So dia jadi negatif 2x2. Okay, so x2 saya ada x3, so x3 sama dengan x2. Okay, cuba kita kembangkan yang ni. Okay, kita kembangkan yang ni. So apa kita dapat? x1, x2, x3 sama dengan negatif 2x2 tambah kosong x3, betul? Sama dengan kosong x2 tambah x3 sama dengan kosong x2 tambah, okay, x3 x2 kosong x3 x21 tambah kosong. Okay, so sekarang kita ada saya dah tak boleh nak ke kiri, ke kanan ni. Okay, so saya simplify benda lah ni kepada matrix term. So x1, x2, x3 sama dengan negatif 2, ni untuk x2, kosong 1, okay. And then plus, ni untuk S2, ni Ctrl C, X2 plus 0 0 1 0 X3. Okay. So boleh tak kita katakan S3 ni, sebab S3 ni satu nombor S ni satu nombor, ikutlah any number. S3 ni kita gantikan kepada S, any number in real number. So apa yang berlaku dekat sini, bila kita katakan ni S, katakan ni S kan, ni lagi senang lah. Yang ni jadi dia susah sikit. Sekejap katakan dia X tu sini. Okey, katakan S3 adalah S. So yang ni akan jadi S. Yang ni akan jadi negatif 2S. Okey. Negatif 2 S. Yang ni kita ada S. Apa ni lah. Okey, tambah S. Okey. And then kita ada S sekali lagi kat sini. So kita boleh buat negatif 2 1 1 S. So for eigenvalue x1 lambda 1 equals to 1, the vector dia adalah yang ni. Ini vektor dia, ni jawapan dia. Okey. Untuk yang ni bila x tu lambda 2 equals to 2, so kita masukkan 2 dalam value dalam matrix tu, cari dia punya ni, and then bermaksud yang ni kita pun akan ada 0 0, maksudnya infinitely many solution. So kita gantikan x2 sama dengan t, and then x3 sama dengan s, sebab kat sini kita ada x1 sama dengan x3, which is kenapa jadi s dengan t, sebab x2 tak sama, dia tak sama dengan x1 x3, dia tak sama dengan x1 x3. So dia adalah nilai yang berbeza. Jadi kita denote sebagai nombor yang subjek yang berbeza lah. Dia S, yang ni T. So sekarang bila kita letakkan S dan T, so kita ada kat sini kita ada sini kita ada ST. So X2 equals to T, betul? Yang ni adalah equals to S. Alright, so X1, X2, X3. So kita ada yang ni kita ada X1 sama dengan S, S2 sama dengan T. Okey, S3 adalah S. Okey, so boleh tak kita pecahkan yang ni? Kita pecahkan dia sebagai ni plus 0T, yang ni plus 0S. Okey, Ctrl C, 0S. Okey, sini saya. Dah habis masa. Okay, sikit lagi. Okay, so sini akan jadi 0T tambah 1S. Yang ni akan jadi T tambah 0S. And then sini akan jadi 0 3 S lah kan. 0 T tambah S. So kita pecahkan TT. So TT akan jadi 0 1 0. Ni untuk T. And then plus 1 0 1. Ni untuk S. So kat situ lah. So that's why dia punya solution jadi macam ni. Okay. This exercise for eigenvalue, eigenvector. So step yang sama. That's all for today. So nanti application. So kita next week dah habis lah matrices. So itu saja. So maybe next week kita buat exercise sikit lah. Boleh? Okay, sorry ambil masa lama sikit. Tak perasan pula.